Hello everyone, this is Shiva, right? So in the previous one, we've seen variable charge density for a sphere, right? They've given volume charge density function, and we did it with finite element method, right? That is, take a small element and then integrate it within the limits, right? So yeah, kind of variation of that problem. So this is a exemplar one, by the way, right? So the problem goes as let the total charge 2q be distributed in a sphere of radius capital R with charge density. So this is the charge density they're given, right? Rho of R is equals to kr, where small r is the distance from the center. Two charges A and B of minus q each are placed diametrically opposite points at equal distance A from the center. If A and B do not experience any force, then the relation between the charges where they placed, that is small a, and actual radius of the sphere, right? So there is a sphere here, and so if I take this as the radius of the sphere, that is capital R, right? And the total charge is 2q, right? Uniformly distributed within the sphere, surface of the sphere. Now inside the sphere, right, what they took is two charges A and B, right, of minus q each, minus q and minus q, right? So this is A and this is A, right? This is actually mentioned in the problem itself, that is, they are diametrically opposite points at equal distance A from the center. So if I take this as center, at diametrically opposite points at distance A, we place two charges minus q and minus q, right? Now in this arrangement, if A and B do not experience any force, right? Now force will be due to this charge on this charge. So let's take one charge. Let's say this is charge A. So if we take this charge A, the total force acting on it should be 0, and the total force acting on would be due to this charge, and also the total sphere, the whatever the charge which is embedded in this one, right? Due to that one also, this minus q will experience some force. So the total summation of that force and due to force due to this one, that should cancel out, right? So when they cancel out, right, what is the relation between A and capital R? That's what they've asked. So now if I compute force due to minus q here, right, force due to B charge on A, right, if I take that, that will be 1 by 4 pi epsilon naught, that is k, right, q1 q2, both are q, minus q minus q, q square by r square, the distance between them, right? So this is A and this is a total 2A, right? So this is force on B, force on A due to B, right? So maybe, right, I've explained correct only, right? Yeah, force due to B on A, that's how I explained. Otherwise, yeah, I hope you got it. Okay, so 1 by 4 pi epsilon naught q square by 4a square, right? Force due to B on A, right? Next one, at this point, right, if I take this one, right, so this distance is A, right? So at this point, if I calculate my total charge, right, you could say, sir, at that point, you could directly take linearly, right? For example, for total volume, that is 4 by 3 pi r cube, the charge is 2q. For this radius, 4 by 3 pi a cube, you could directly take this into this by this one, that is 2q into a cube by r cube. This would have been right when the charge distribution is linear, right? Charge is equally distributed, right? Linearly distributed, uniformly distributed. But it is not so, because there is a I mean charge density is there, that is it is not uniformly distributed, some function is there like the previous one, right? So rho of r is there, so we have to take again elemental method, and from that we need to compute what is the charge right at this point, and we need to find force due to that charge on minus q, that is a charge, right? And then we have to add these two and equate to 0, right? Take the result and equate it 0, then we'll get a relation between these two. So to find the charge here, basically we have to find the force here, right? So for force we need charge. We already know one charge which is already the given, that is a charge, that magnitude is minus q, but we need charge here, right? So we need force, for that we need charge. Force is also can computed by electric field, right? We can find electric field here also. So to find electric field here, we need to apply Gauss law, because we know the surface area, that surface area of the sphere which is enclosed, right? That imaginary Gaussian sphere, that volume we know, right? 4 pi a cube, right? That area we know, E dot ds is equals to q by epsilon naught. That area we know, but since I've not discussed for Gauss law formally, right? Since we are discussing Coulomb's law, let's go with Q method, right? That is computing charge, right? So if I go by that method, right? So I need Q here. So Q at A is equals to integral rho dv, right? Integral rho is kr, and elemental volume, right? That shell's volume at that distance, not shell, that the complete sphere's volume. That is, if I take the radius is a square, that is 4 pi a square surface area into thickness some dr, right? Well, if let's take r, because a is, I'll put the limits, then we'll get from 0 to a, right? Okay. So qa is equals to, so 4 pi k integral r cube is r power 4 by 4, going from 0 to small a. So qa is equals to 4, so it will be pi k e power 4, right? And by the way, this k is not 4 pi 1 by 4 pi epsilon naught or SHM constant or anything. This is the k which they have given in the charge distribution function, that is kr, right? So we need value of k, right? For that, what do we know is that 2q is the total charge embedded. So if I take this same method and apply it for a whole sphere, then I'll get total charge of the sphere is 2q is equals to integral rho dv, right? 2q is equals to integral rho is kr, and dv is again at some distance, if I consider at r 4 pi r square, and elemental thickness is dr, right? And the limits are from 0 to complete sphere now, so that is 0 to r. So 2q is equals to 4 pi k integral r square, r square into r cube, integral r cube r power 4 by 4, and if I substitute r here, then we'll get r power 4 by 4. So 2q is equals to pi k r power 4, right? Sorry, excuse that. So from here k I can write as 2q by pi r power 4. These are all known quantities and there is no unknown quantity, and I'm putting this k here. Then I'll get qa, right? The total charge at this point. So it will be pi, k is 2q by pi r power 4 into a power 4. Pi, right? So q is 2q a power 4 pi r power 4, right? Now if I take Coulombic attraction, right, due to this one and the minus q here, right, then big force. Let's say this is q2 minus this is qa is equals to k 1 by 4 pi epsilon naught q1, that is minus q, into this q, right, that is 2q a power 4 by r power 4, right, k q1 q2 by r square, right. So this distance is again a square, right. So this is the force due to qa, right, and due to b, this one, right, and the resultant should be 0. The net, the no experience, a and b do not experience any force, they're saying. So if I equate it, so these two, then I'm writing this expression here, right. You can write this plus this equal to 0, because minus is there, then you'll get the same thing. So I'm directly equating this one and this one, so that will be 1 by 4 pi epsilon naught q square by 4a square, right. So q square 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught whatever is okay, so a square, right. So only 4 is there here a power 4 and here r power 4, and by the way 2 is also here, so 4 into 2, so it will be 8 a power 4 is equals to r power 4, and a power 4 is equals to r power 4 by 8. So from here a I can write as r by 8 power 1 by 4, right. So this is our required relation, and in the options they given, they took a power 1 by 4 to the numerator, so that you'll get minus here, so this is your option, right. So I hope you got the point that again this is variable charge density, so we have to do it by elemental method. So elemental method always takes some arbitrary distance, arbitrary element, that is shell element, right, at distance r, and within the whatever distance we get, we'll compute that limits, right. Initially we need up to a, finally in the second case we need up to 0 to r. You could compute this first and this second, it doesn't matter. What I'm trying to tell is, you take certain element, right, at some arbitrary distance r, and with that thickness dr, right, and then you take a substitute that dv, and then you substitute the whatever the limits is there, appropriate limits, and then you'll get the total charge at that point, due to since there is a variable charge density. Okay, so I hope you understood it, and if not, please do let me know in the comments. Okay, so I have another one, the last model, next one, that is if I place a charge, right, small charge inside a ring, what is the tension that will develop in the ring, right, which is a pretty standard question. Okay, I'll discuss that in the next video, and thank you very much.